The study guide for test 1, unit 3. All right, solve the equation by factoring. So when you see the phrase by factoring, that's when you want to make sure that you're using your box to factor. So here, we want to make sure that all of our terms are on the left side. We want this equation to equal 0. So we are going to move over the 2x by subtraction, and we are going to move over the 24 with subtraction. That's going to give us x squared minus 2x minus 24 equals 0. Now that it's equal to 0, we want to go ahead and see if there is any GCF. So we have a 1 in front of the x squared, a 2x, and a 24. There's no GCF here, so we're going to go straight to our box. So I draw our box. We set it up. The x squared term goes in the top left. The negative 24 goes in the bottom right. And outside on the corner is negative 2x. And then x squared times negative 24 is negative 24x squared. We need to find two values that multiply to be negative 24x squared, and then two values, the same two values that will add to be negative 2x. So our combination will be negative 6x and positive 4x, because negative 6x times 4x is negative 24x squared, and negative 6x plus 4x is negative 2x. All right, so x times x makes x squared, x times 4 makes 4x, and x times negative 6 gets us negative 6x, and negative 6 times 4 is negative 24. So now our factors are x minus 6, x plus 4 equals 0. Now we'll use the zero product property where we'll have x minus 6 equals 0 and x plus 4 equals 0. You simply solve this equation by adding 6 to both sides, so x equals 6. And for this equation, x plus 4 equals 0, minus 4 to both sides, so x will equal negative 4. So these are our two x-intercepts. Sometimes they're called zeros, and sometimes they're called roots. So three different names that all mean the same thing. Okay, another example. We have 5x squared minus 21 equals 8x. Once again, before we can start factoring, we need to move everything to the same side. We're going to move the 8x over to the left side with subtraction. And so I'll have 5x squared minus 8x minus 21 equals 0. You always want it to equal 0. And remember, it's going to go x squared, x, and then a constant. You always want to go in that order before you start factoring. So now we're going to go ahead and set up our box. And then we're going to do 5x squared times negative 21, which is going to give us negative 105x squared. We got to find two values that are going to multiply to be a negative 105x squared and combine to be negative 8x. So after a little work, I figured out that we're going to have negative 15x and 7x. That's going to give us negative 105x squared. And negative 15x plus 7x is negative 8. So we fill them into our box. And then we go ahead. We need two values that are going to multiply to be 5x squared. So if I put a 5x here and an x here, there's nothing times 5x that gets me a 7x. So I need to move this 5 up to the top, because 5x times negative 3 would get us the negative 15x, and x times 7 would give us the 7x, and so 7 times negative 3 gets us the negative 21. So now we know it actually all works out when we check our multiplication. So now I'm going to simply write the factors. Once again, this is all going to equal 0. So x minus 3, 5x plus 7. Using our zero product property, we'll have x minus 3 equals 0, 5x plus 7 equals 0. We're going to solve the equation by adding the 3x over. When we do, x will equal 3. We're going to minus the 7 over. Once again, trying to get x by itself. Then we're going to divide both sides by 5. So we're going to be left with negative 7 over 5. And now we have our two x-intercepts, also known as zeros, also known as roots. And once again, if you see the phrase factoring, you should be using your box. Okay, solve using the square root method. So the square root method usually shows up for us when the only thing in our equation is x squared. When you just have an x squared, that's 99% of the time you want to use this method because it's the fastest and the easiest. So what we want to do, we want to get our x squareds on one side of the equation and our constants on the other. So this negative 4x squared, I'm going to move it over to where the 5x squared is by using addition. I'm using addition because I am passing an equal sign, which means I need to use the opposite operation. So these are going to cancel out because that equals 0. 5 plus 4, that's 9. So I have 9x squared minus 4 equals negative 3. So now I got my x squareds on the left side. So I'm going to be moving my constants to the right side. So since it's minus 4, I will add 4 over. So I'm going to have a 1 equals 9x squared. Now, once again, I want to go ahead and get x squared by itself. So I'm going to divide both sides by 9. So I'm going to have x squared equals 1 over 9. And I want to get rid of the square because I want to know what x is. So I'm going to square root both sides. So I have x equals, now don't forget, when we square root both sides of an equation, we must include the plus and minus sign. Now I have the square root of 1 over 9. Now we can actually square root those two numbers and get nice whole numbers. So the square root of 1 is 1, and the square root of 9 is 3. So our answers are plus and minus 3. We have two answers here. One that's positive 1/3, and one that is negative 1/3. Our next problem, problem 4, is also going to be solving using the square root method. Once again, we want to get the x squareds on one side and the constants on the other. So I'm going to take this 5x squared here, and I'm going to subtract it this time because it's currently a positive, so I want to use the opposite operation, which is minus. And I'm going to bring it over to the 12x. These will equal 0, so I'm just going to cross them out. 12x squared minus 5x squared is going to give me 7x squared. I have my plus 9 and equals 100. I am then going to subtract 9 over to the 100 because I'm trying to get x squared by itself. So I'll have 7x squared equals 91. I'm then going to go ahead and divide both sides by 7 because I want to get x squared by itself. So I'm going to have x squared equals 13. 91 divided by 7 is 13. I'm going to get x by itself by square rooting. And so I'll have x equals the square root of 13. And once again, don't forget that plus and minus sign because we square rooted both sides of the equation. Okay, identify the discriminant and state how many / type of solutions there are. So here we go. We got ourselves a formula. This is our discriminant formula. It's b squared plus negative 4ac. And we're just going to plug it in, and based on the kind of number we get, will tell us how many solutions there are. So keep in mind that if our answer to this formula is positive, so a number greater than 0, we're going to have two real solutions. If the answer we get from this formula is the number 0, we're going to have one real solution. And if the answer we get from this is a negative number, then we're going to have two imaginary solutions. Okay, so first we've got to make sure that everything is on the same side of the equal sign and the equation's equaling 0. We currently have that set up for us. So we care about identifying what is A, B, and C. A is the number in front of x squared. If you don't see a number, it's an invisible 1. The number in front of x is our b value, and the number without the variable is our c value. So we have b squared plus negative 4ac. So we're going to have 4 squared plus negative 4 times 1 times 4. I recommend you just go ahead, you type that entire thing into your calculator. When you do that, you should get the answer of 0. And since we got the answer of 0, if we go back up to our little cheat sheet up at the top, 0 means one real solution. Okay, looking at number 6, same idea. The number in front of x squared, that's the a value. The number in front of x is the b. And the constant is the c. So plugging into our formula, b squared plus negative 4ac, we will have 6 squared plus negative 4 times 6 times 4. Once again, once we type this entire thing into the calculator, we're going to get ourselves a negative 47. Since that number is negative, we're going to say there are 2 imaginary solutions. Number 7. The number in front of x squared is 10, so that's our a. The number in front of x is 9, so that's our b. And negative 1 is going to be our c. Using our formula, we have 9 squared. We have a being 10 and c being negative 1. When we type this entire thing into the calculator, you should get the number 121. And since that's a positive number, we're going to have 2 real solutions. Make sure you memorize your formula. Okay, our next problem is solve by completing the square. Solve by completing the square is the one with the blank spaces. So one thing we want to do is to get the x squared and the 16x by itself. We want to isolate that. So we're going to move the 48 over with subtraction. That means this is going to cancel out, and we're going to have x squared plus 16x plus blank space equals negative 45 plus blank space. From here, we are now going to take the b term, the term in the middle here, and we're going to always divide this by 2 every single time. So 16 divided by 2 is 8, and 8 squared is 64. What we do to one side of the equation, we have to do to the other. So if we added 64 here, we have to add 64 to the right side as well. From there, we have now created a perfect square trinomial, which means we're going to factor this. But to save ourselves time, we're going to use a shortcut to factoring this perfect square trinomial. So for a perfect square trinomial, the factors are always going to be the same. So if you had a box, the factor you had on top of the box and the factor you had on the left side of the box are always going to be the same. That always going to be the same expression. That's why we have this square here, because there's actually 2 of them. Now, to figure out what these values are, it's pretty easy taking the shortcut. Since we're using the variable x in our problem, the x is going to be the first thing we write in our parentheses. The first sign you see here is going to be the first sign you see here. It's going to be the sign in the parentheses. When you went 16 divided by 2, that gave you 8. 8, that's the number that goes here. So if you were factoring this, you would actually have x plus 8 and x plus 8. On the right side, negative 45 plus 64 is 19. Okay. Once we have this, I'm just going to rewrite it because we have a lot of arrows everywhere and I don't want to cover them up with the rest of my work. So you always have a clear view of what's happening. So now I want to get x by itself, but it's trapped inside these parentheses with the square on it. To get rid of the square so I can get to the x, I'm going to do the opposite of squaring, which is called square rooting. I'm going to do that to both sides, because if I do something to one side, I got to do it to the other. So now these will cancel out, leaving x plus 8 equals, and since we square rooted both sides of the equation, I must bring in my plus and minus sign. Once again, I'm trying to get x by itself, so I'm going to minus the 8 over, so x can be by itself. So I have x equals negative 8 plus and minus the square root of 19. Now, I want to see if I can simplify 19, but the only numbers that multiply to give me 19 are 1 and 19. Which means I can't make that any smaller. So here are my two x-intercepts. Okay, solve by completing the square. Once again, that's going to be the one with the blank spaces. We're going to go ahead and we're going to get the x squared and the 2x by itself by moving our 79 over to the right side with subtraction. So now we're going to have x squared minus 2x plus blank space equals negative 73 plus blank space. So from here, we want to fill in the blank space. So we're going to take our b value, the value in the middle, and we're always going to divide it by 2. So 2 divided by 2 is 1, and then we're going to square it. What we do to one side of the equation, we've got to do to the other. So we're going to have a 1 here and a 1 here. Once again, we're going to do, we create ourselves a perfect square trinomial. So we're going to take our shortcut to factoring that, where we're going to have parentheses squared. Since we're using the variable x, we're going to start off with an x. Since we have a minus sign here, that first sign that we have, that's the sign that goes inside the parentheses, so it's going to be a minus sign. We have 2 divided by 2, and that gave us a 1 here, and so that 1 is the number that ends up there. And so negative 73 plus 1 is going to give us negative 72. Once again, I'm going to rewrite this because I have arrows kind of going everywhere, and I don't want to get it all cluttered. So we have x minus 1, 72. All right, so now we're going to go ahead. We're going to get rid of this square by square rooting both sides of the equation. So we're going to have x minus 1 equals plus and minus, because we square rooted both sides of the equation. Now this time you see we have a negative inside the square root, which means we're going to bring an I into our problem and make that a positive 72. Once again, if you have a negative inside the square root, that means you have an imaginary number. And we're going to represent that with an I instead of the negative sign inside the square root. Now we're going to go ahead and get x by itself by adding the 1 over. So now our final answer is going to be x equals 1 plus and minus I square root 72. But before I finish, I should always check about my radical. A 72 is a pretty big number, which means maybe I can simplify that number to become something smaller. So let's see if that happens. The square root of 72. Two numbers that multiply to be 72 could be 2 times 36. And maybe you thought of a different pair of numbers that multiply to be 72. It's all going to work out to be the same, no matter what combination you use. Well, two numbers that multiply to be 36 is 6 times 6. That 36 is no longer there because I've turned it into 6 times 6. Now, I just noticed that I have two numbers that are the same. I have two 6's. Well, if we have a pair of 6's, we can pull it outside of the radical sign, and the only number left over is the 2. It had nothing to pair up with, so it stays inside the radical sign. So I can simplify my answer down to x equals 1 plus and minus 6i square root 2. And this is the simplified answer for your problem. That's the answer we're looking for on the test. Okay, so now we're coming across more completing the square problems, but these are the tougher ones. And they're tougher because you'll notice that this time we have a number in front of x squared, which means we have to do a little extra work this time. We still want to get the x squared and the 16x by itself. So we're going to go ahead and we're going to move this 61 over to the right side with addition. And so what we're going to have here is 8x squared minus 16x equals 64. Now that we have that set up, once again, we have this number in front of x squared, which means we need to GCF. And for the problems that you're going to come across in this course, your GCF is always that number in front of x squared. So I'm going to pull out an 8. So 8 times x squared would get me 8x squared. Then 8 times negative 2x would get me negative 16x. One of the most common mistakes people make is they're going so fast through the process, they forget that this number should be definitely smaller than that one. And it's because you're doing negative 16 divided by 8, which is where this negative 2x comes from. Please be careful on your test. Slow down. Make sure you're doing it right. Then we have our plus blank space equals 64 plus blank space. So just like we've done previously, we want to go ahead and take the middle term, the b value, and we're going to divide it by 2. We always divide it by 2. So we're going to get a 1. Then we're going to square it. But this time, it only goes there, not on the right side. The 1 will only go here. And that's because I really didn't add 1 to my problem. I added a lot more than what it looks like. And that's because if I look at the whole problem here, I have 8 parentheses x squared minus 2x plus 1 close parentheses. What's really happening is that 8 gets times the 2x squared. That 8 gets times the x squared, which gets us 8x squared. That 8 gets times to negative 2x, which gives us negative 16x. That 8 would also get times to that 1, and 8 times 1 is an 8. So I really brought an 8 into my problem, which means if I added 8 to the left side of the equation, I have to add 8 to the right side of the equation to keep my equation balanced. So now that I have a properly balanced equation, I'm going to go ahead and take that shortcut to factoring for this perfect square trinomial. And since I had a number 8 in front of the parentheses, I'm going to have a number 8 in front of my parentheses here too. Once again, since we're using the variable x, we're going to have x. The very first sign we come across in our parentheses is this negative, so this negative will end up inside the parentheses. Since we did 2 divided by 2, which got us a 1, we're going to bring a 1 into our parentheses. And then we have 64 plus 8, which is going to give us 72. Once again, we're going to go ahead and we want to get this parentheses squared by itself, which we have an 8 in front. This is 8 times that parentheses, so we want to undo that multiplication by dividing. So these 8s would divide away, getting us down to x minus 1 squared equals 9. Now it's very similar to the problem we've been doing. We want to get rid of the parentheses with the square by square rooting both sides of the equation. And we're going to end up with x minus 1 equals plus and minus, once again, plus and minus because we square rooted both sides of the equation. The square root of 9 is 3, not square root 3, just 3. Once you've actually done the calculation, that square root sign goes away. We're then going to go ahead and add the 1 over to get x by itself. So now we have x equals 1 plus and minus 3. Now, since we have a bunch of whole numbers here, there's no radicals, we need to split it off to find those actual x values, those actual x intercepts, where we would have 1 plus 3, which is 4, and 1 minus 3, which is negative 2. And so those are the two x-intercepts for this quadratic. All right. Our last, solve by completing the square. Once again, in this one, you'll notice that we have a number in front of x squared, which means we're going to have to do a little extra work here. So we're going to go ahead and we're going to get the x squared and the x by itself. We want to isolate them. We want to take that 76 and we want to move it to the right side. So I'm going to minus 76 over to where the 6 is. And we're going to have 7x squared plus 14x equals negative 70. Once again, since we have that 7 in front of x squared, we're going to factor out a 7. And so that means we'll end up with x squared inside the parentheses. 14 divided by 7, that's going to give us 2. So 2x plus blank space equals negative 70 plus blank space. We're going to go ahead and do what we've been doing. We're going to take this middle term, this b value. We're going to take that 2, and we're going to divide it by 2. We're always dividing by 2. Doesn't matter what the number is on top. We divide by 2, and we get 1 squared. We're going to put 1 squared, which is 1 right here. Now, once again, it's only going to go in this location, and that's because we really have a number in front. So we're going to go 7 times 1, which gets us 7. Then we're going to have ourselves our factors. So we're going to essentially take a shortcut to factoring this perfect square trinomial. That's x squared plus 2x plus 1. Shortcut to factoring here for that. This 7 is going to go in front of the parentheses. We're using the variable x, so we're going to have x. The sign we come across right here is a plus, so we're going to have a plus. This right here, this 1, is the number that goes inside our parentheses here. And then negative 70 plus 7 is going to give us negative 63. We want to get the parentheses squared by itself, so we're going to have to divide by the 7 that's in front of the parentheses. Once again, we're trying to get x by itself, so that's why we need to get rid of that 7. And so negative 63 divided by 7 is negative 9. We're going to square root both sides of the equation. So we'll have x plus 1 equals plus and minus, because we square rooted both sides. We have a negative inside that radical, which means we're going to bring the letter I, and then the square root of 9, like so. Now the square root of 9 is really 3. So what we have here is x plus 1 equals plus and minus 3i. We want to go ahead and get the x by itself. So we're going to move that over here. So we are going to minus the 1 over. So we're going to end up with x equals negative 1 plus or minus 3i. Now, since there's an I in this problem, we're not going to split the problem apart and find the two separate answers. We can just leave it in this form. Solve by using the quadratic formula. So right here, the quadratic formula is presented to us. This, once again, lets us find x-intercepts. Solve by factoring, solve by the square root method, solve by completing the square, and solve with the quadratic formula, all find us x-intercepts. So for the quadratic formula to work, all the terms have to be on the same side of the equal sign. So it should be equal to 0, which it currently is. It's set up for us. We just need to label which one is A, B, and C. A is always the number in front of x squared. B is the number in front of x, include your sign. And C is the constant. So we're just going to fill it into our formula. So we have x equals, now we have a -5 for our b, but our formula says -b, so it's going to turn it into a +5 plus or minus square root. Then we have parentheses -5 squared, because it said b squared, plus our -4 times a times c. So times 10 times 1 all over 2 times a, and our a is a 10. So the next thing, your next step is you're going to take your calculator and you're going to multiply what you see underneath the square root. Sorry, not multiply. You're going to calculate what's underneath the square root. So when you go ahead and do parentheses -5, close parentheses squared, plus parentheses -4, parentheses 10, parentheses 1, you're going to get the number, oops, you're going to get the number x equals 5 plus or minus the square root of -15 over 2 times 10 is 20. Once again, if you do not put parentheses around this number when you type it into the calculator is going to give you the wrong answer. Please be careful. Make sure you're using parentheses. So we have a negative sign inside of the square root, which means that we have an imaginary answer, which means we should write an I out in front of the square root, and our -15 is now a +15, and this whole thing is over 20. Now, we have a 15. We need to see if we can simplify that. So the square root of 15, two numbers that multiply to be 15 is 3 and 5. I can't make these numbers any smaller because they're prime numbers. Therefore, I can't simplify this because there's no pairs. So my answer is left like this. Our next problem is another quadratic formula problem. So our a value is the invisible 1 that's in front of x squared. Our b value is the number in front of x. And our c value is the constant, the one without the variable. Once again, you'll notice that the entire equation is set equal to 0. If your equation is not set equal to 0, you can't use the quadratic formula. Make sure it always equals 0. Have everything on the same side of the equal sign. So we're going to plug into our formula. Now we have a -b plus and minus. That -b, our b is a +9, so we plug that +9 into the -b, it turns it into a negative. So we have -9 plus and minus square root, and then we have b squared, so we're going to have 9 squared plus -4 times a, which is a 1, times c, which is -22, all over 2 times a, which is a 1. So we are going to have x equals -9 plus and minus the square root of, and once again, you're going to go ahead and you're going to take your calculator and you're going to type this into your calculator. Parentheses 9 squared plus a -4 times a 1 times a -22. And when you do that calculation, you're going to end up with 169. When you do that, on the bottom, we're going to have 2 times 1, which is going to be 2. So now we're going to have -9 plus and minus. Now the square root of 169 is going to be 13. That is all over 2. Now here you'll notice that we have a -9, a 13, a 2. Those are all nice whole numbers, which means if you get to this point, you need to separate your problem out to get both answers. So you'll have -9 plus 13 divided by 2, and then -9 minus 13 divided by 2. So we're going to get ourselves -9 plus 13, add that together, divide it by 2, we'll end up with 2 as one of our x-intercepts. -9 minus 13 divided by 2 is going to give us -11 for our other x-intercept. And so now we've solved by using the quadratic formula. Okay, last problem for quadratic formula. Once again, you want to label your a, b, and c. So our a is the number in front of x squared. Our b is the number in front of x. And our c is the number without a variable. So if we go ahead and we plug it in, we're going to have x equals, once again, we have a negative b for our formula. Our b is a positive 2, so it's going to turn into a negative 2, plus and minus the square root of. And then we have b squared, so we're going to have 2 squared plus -4 times a, which is 5, times c, which is 9, all over 2 times a, which is 5. Once again, we're going to go ahead and we're going to type everything underneath the radical sign into the calculator. So we'll have x equals -2 plus and minus the square root of -176 all over 10. Now inside that square root, you will notice that we have a negative sign, which tells us we have an imaginary answer. So we're going to have -2 plus and minus I square root 176 all over 10. Now 176 is a pretty big number. I'm pretty sure we can simplify that. So I'm going to go over here to the left. I'm going to try to simplify 176. So two numbers that multiply to be 176 is 2 times 88. 88 is 8 times 11. That 88 is no longer there because we turned it into an 8 times an 11. 8 is 2 times 4. Now the 8's no longer there because I've turned it into 2 times 4. Now 4 is 2 times 2. The 4 is no longer there. Now all the numbers I have in this problem are now prime factors. So I'm looking for pairs. I have a pair of 2's here. I have a pair of 2's here. Sadly, nothing for the 11 to pair up with. So I currently have 2. That 2 represents that circle. 2. That 2 represents that circle. Square root 11. Because 11 had nothing to circle with, so it stays inside the radical. So now 2 times 2 is 4. Square root 11. So now back to my quadratic formula, I can go ahead and set up my answer to look more like this. I have a 4 in front of the radical, so I'll have 4i square root 11 over 10. So I've replaced the square root of 176 with the 4 square root 11. Now I have another thing. I have a -2 here, a 4 here, and a 10. You always want to look at those three numbers. If you can reduce those three numbers by a single value, you need to do so. So the biggest number that goes into a -2, a 4, and a 10 is a 2. So I'm going to reduce this by 2. So -2 divided by 2 is -1, plus and minus. 4 divided by 2 is 2, so I have 2i square root 11 over 10 divided by 2 is 5. And there is my simplified answer. Okay, this problem says state the solutions. So as we've been going through this entire study guide, the majority of the problems that we have been doing have been solving quadratics. And what you always end up finding when you're solving these quadratics, doesn't matter what method you use, you're always finding x-intercepts. When it says state the solutions and they're showing you a graph, they're asking for what are the x-intercepts? That's what they want to know. So if we look here, we see the graph touches the x-axis right here at -3, and this one is right between 3 and 2. So that's 2.5. So our two answers is x equals -3 and x equals -2.5. Those are the x-intercepts. Those are the solutions to the quadratics. So keep in mind, when you solved by factoring, quadratic formula, completing the square, and the square root method, oops, all of them, we're finding you x-intercepts, which sometimes are called zeros and sometimes are called roots, but they're all x-intercepts. Okay, we have the height h in feet of a toy rocket launched from the top of a 20-story building x seconds after it is launched and can be modeled by the function, and they give us this equation here. Part A asks us to determine the zeros. Remember, the zeros are the x-intercepts, which means we want to solve this. So we want to set this equation equal to 0 so we can find those x-intercepts, those zeros. So there's a lot of different ways you can do this. I suggest factoring. When I'm looking at this problem, I can see I have an even number, an even number, and an even number. That tells me there's a GCF here. I think -16 is the GCF. So I'm going to go ahead and I'm going to pull out -16. So -16 divided by -16 is 1. So I have 1x squared. 32x divided by -16 is going to get me -2x. 240 divided by -16 is -15. And so there was definitely a GCF of -16 here. Now remember, I'm trying to determine the zeros, those x-intercepts, which means my equation should equal 0. Now I'm just going to continue with the solving. I'm going to go ahead and do the factoring method. So I'm going to make my box. I'm going to put the x squared in the top left, the -15 on the bottom right, the -2x out here off to the corner, and then x squared times -15 is -15x squared. Once again, I need to find two numbers that are going to multiply to be -15x squared, and those same numbers are going to combine to be -2x. So from here, two numbers that would be -5x and 3x would be the correct combination where this makes sense. So I'll have -5x here, 3x here. So x times x is x squared. X times 3 is 3x. X times -5 is -5x. -5 times 3 is -15. So I have my factors. So I have -16 parentheses x minus 5 x plus 3 equals 0. Using the zero product property, I'll have x minus 5 equals 0 and x plus 3 equals 0. I'm not going to do -16 equals 0 because -16 doesn't have a variable with it, so it's not going to get me an answer. It's just part of the problem. So I'm going to solve by adding 5 to both sides, which is going to give me x equals 5. I'm going to minus 3 to both sides, which gives me x equals -3. So those are my two x-intercepts. Those are the zeros of this quadratic. Part B is saying, interpret the zeros of the function in the context of the problem. So this is a typo. This is supposed to be interpret. So we're going to interpret the zeros. So first thing we have to understand is, what does the x mean in the story, and what does h of x mean in the story? Anytime you're trying to interpret what x-intercepts are, or any point, what we care about is what do those two things mean? So before I try to make a sentence, let's just kind of dissect this. H of x, what the equation equals. It's letting us know in the very first sentence, the height, h, that's referring to h of x, in feet of a toy rocket launched from the top of a 20-story building. So h of x is referring to the height of the rocket. Height of rocket. Right? Now the question is, well, what does x mean? Well, it's telling us in the story. X seconds it is after it's launched. So x is referring to time. X is seconds. So x is referring to time in seconds. So now when it says interpret the zeros of the function in the context of the problem, this is a lot easier. Because once again, this h of x, we turned it into 0 when we solved. Since we turned it into a 0, we're saying the height of the rocket is at 0. And that's going to happen when x is 5 and when x is -3. So at 5 seconds and at -3 seconds. So let me get a better color. The height of the rocket is 0 feet at 5 and -3 seconds. Part C, determine which 0 is not viable. Classic problem, and very easy to know. Time always moves forward. Time must be positive. You cannot have negative time. Therefore, the x-intercept, -3, referring to seconds, you can't have -3 seconds. So -3 is not viable. So -3 is not viable because you can not have negative time. Okay, last problem. A statistician for an outdoor company analyzes data for the years 2007 to 2014 to help inform the company about trends. The function r of x equal -10, parentheses x minus 5, close parentheses squared, plus 600 models the number of people ages from 6 to 17 in the tens of thousands are who listed running as a hobby for X years since 2007. Before we continue with the problem, let's make sure we understand what does r of x mean in the story and what does x mean in the story. So r of x, which is essentially referring to our y value in this problem, is referring to the number of people ages from 6 to 17 in tens of thousands who listed running as a hobby. So number of people ages 6 to 17 listed running as a hobby. And then we have to ask ourselves, what does x mean in the story? X is referring to the years since 2007. So it's referring to time, specifically years, since 2007. So if we look at this graph over here, this 0 that we have, that's referring to the year 2007. Now our story is telling us that this is taking place between 2007 to 2014. So we only care about the years from 2007 to 2014. So now we kind of understand a little bit more about the story in which each variable is referring to. We can go ahead and start answering some of these questions. It says, identify the vertex of the equation. What does it represent? So if we look at our equation, this equation is set up for us in vertex form. So vertex form basically has it set up so we can see the vertex. So our vertex is going to be, once again, we look inside the parentheses, we switch the sign, so the first value is going to be 5, and then our back value, the k value, that's going to be 600. So our vertex is at 5, 600. This is also asking us to state what this represents. So number one, this is going to represent the highest point of our graph. It's going to represent the highest point in our graph. 2, what it represents in the story is, since the x is referring to years and it's a 5, it's referring to the fact that 5 years since 2007. And the 600 is representing the number of people in tens of thousands that from ages 6 to 17 listed running as a hobby. So we can say 600 in tens of thousands ages 600 people, 600 people in tens of thousands from ages 6 to 17 that listed running as a hobby. So I'm going to go ahead, I'm going to take a moment, I'm going to take that vertex and I'm going to plot it on our graph. So at 5 on the x, 600 on the y. So right there is my vertex. Okay, part B. It says find and interpret the y-intercept of the function. So the y-intercept is always referring to when the x is 0, you'll find a y value. Well, we have an equation that has an x and a y. Once again, r of x means y. So if we know the x has to be 0 to be a y-intercept, we're just going to plug 0 into our equation. So we have r of x equals -10, 0 minus 5 squared plus 600. And so 0 take away 5 is -5. That's being squared. And then -5 squared is 25. And then -10 times 25 is going to be -250. And then we have -250 plus 600, which is 350. So our y-intercept is 0, 350. So once again, the question is asking us to interpret what that means. So once again, since x is referring to the years since 2007, and our x is 0, we're actually talking about the year 2007. So in 2007, 350 people in tens of thousands, so a lot of them, from ages 6 to 17 listed running as a hobby. All right, so now we can kind of finish doing this graph, because part C asks us to graph the function using the vertex, which we already graphed, and the y-intercept. And we found out the y-intercept was 0, 350. So at 0 up to 350, that's going to be right here. But I want to do a full graph. Remember, this is a parabola. We've been talking about parabolas this entire chapter. So we have to remember something from the first quarter, is that a parabola has an axis of symmetry, which is an invisible line that goes straight through our vertex that cuts the graph perfectly in half. Therefore, parabolas have symmetry because of that, which means if I have a point that's 5 units to the left of the blue line, then I have another point 5 units to the right of the blue line. And now I can go ahead and graph my parabola. Now part D says, what is a reasonable constraint for the function? When it's asking that, it's talking about what x values make sense in our story. So remember, again, if we look back at the story, this equation is talking about the years 2007 to 2014. And we showed earlier that 0 on our graph here is referring to the year 2007. So 0 is the smallest number we can have in our domain. But what's the largest number? Well, we ask ourselves, how many years does it take to go from 2007 to 2014? Well, 2007 plus 7 years is 2014. Therefore, 7 is the largest x we can have in our story. So therefore, the constraint, the part of the graph that we care about, is purely from when x is 0 to x is 7. Everything else is just extra. It's not necessary for our story.